Hello, this video will help you understand how to do problem number 20 in chapter 7. In order to do this one, really you just got to look at the diagram they give you. So I'm just going to make a rough of what it looks like, or at least the parts that matter. I know it looks more like a bell curve, but that doesn't really matter. So let's see, this is going to be 250, so 2 about here. So that'd be 100, 200, every 4 boxes. Oh, and that'd be 300. Fine, I made that too big. That's fine. I know it looks different than that, but my labels will make it so it's the same as what you're looking at anyway, so it doesn't matter. This is a force, and it's in newtons. Oops. Down at the bottom, they show something like here is 0.01, and then 0.02 is over here, somewhere like that. And it starts at 0. So this is the time in seconds. Now they ask you to figure out the total impulse given on the ball. If the mass of the ball was, so the mass of the ball is 0.060 kilograms. So with this in mind, the separation that we need to deal with for A and B is first just focus about the impulse involved. Okay, so A, you're finding out impulse. Hopefully you remember that impulse is a force multiplied by the time. Well, if you got that far, you'd realize there's a force here and there's a time here, so that should make it really easy to figure this out. Now, the mark up here is the maximum force. Actually, let's do it in blue. So this is the maximum force. Down here, obviously, that would be the minimum force. Okay, we don't want to use either of those because the maximum force is only applied for a very brief moment. So we're going to look for the force that's in that range, the average. So just take the maximum force and divide it by 2. So you're going to have, okay, the change, delta F, change of the force, is going to be 1/2. And the red line looks like it's about 250. So you just write, okay, a positive 250 newtons. Okay. And you would then be able to look at the time change. So they have only 3 boxes between here and here, so I'll try to break them up pretty evenly, but they have 3 boxes there, okay? And they have the 1/100th of a second equal 5 boxes. Well, the space between here and this one on your diagram on the computer is 2 boxes, which means the space between here and here, so this space, is 1/100th of a second. So you can just go, okay, I know my time equals 0.01 seconds. This is what it means, by the way, when it says using graphical methods. Okay, you're just looking at the graph and figuring this out. So we can go ahead and put in the values of the force and time. Obviously, half of 250 is just 125. So I'm going to have J equals positive 125 newtons, and then this time is 0.01 seconds. You'd have the impulse would equal positive 1.25 newton seconds. Now the sig figs on this one is tricky. The graph technically gives you one value for the time, and whether or not it's giving you 1 or 2 values for the force, you're not sure. Because you're rounding the number 250 to 2 digits, I would answer it with 2 digits. They do give you the opportunity. If you look at the time, yes, the scale or the intervals they give you are based on 100th, and it gives 1 digit, but they do give you the ability to break those down into 5. So you could actually break that down more accurately to 2 digits as well. So I understand if you made a mistake on this and you rounded it to 1 digit, but 2 digits would be fine. In addition, some people would just keep the 3 because you're not sure and you're just looking at the graph. So I did not mark you wrong on this if you didn't have the right significant figures. Okay, but based on the mass and based on the fact that they have those pieces in between, 2 sig figs would have been most appropriate. You would have had the impulse equal to a positive 1.3 Newton seconds. And that's for part A, because of the mass and because of the fact that you can break that graph down into pieces. Okay. Now for part B, we have to figure out the velocity. So B, trying to figure out what does V equal. Is this velocity after being struck? Oh, and we're saying it starts from rest of 0. So initial velocity is 0 meters per second. So we're going to have the impulse equals the change in momentum. So that's just going to tell us that the impulse will equal the mass times the final velocity minus the mass times the initial velocity. Well, all that was 0. So if we're going to isolate for the velocity, we just need to say v final equals j over m. Don't use the rounded number, so you'd have v1 equals a positive 1.25 newtons times seconds over 0.06 kilograms. I'm going to zoom out. Yeah, that's plenty of room. And so you get an answer. Let's do it here. You get an answer that's a positive 20.8 meters per second. And again, with 2 sig figs, you'd have positive 21 meters per second. Okay, so again, I understand if you had a little trouble with the sig figs on this, but they gave you 2 sig figs for the mass, and you can break the graph down, the intervals on the graph down into 2 sig figs as well. Okay, it's like 250, 150, 50, and then you can break down the hundredths as well. So that's why it would be a problem with 2 sig figs. Okay.